These notes are for factoring special cases. So basically we're still going to be factoring like normal, except these are special cases of quadratics. So sometimes we might be able to do a shortcut, and sometimes we have to do a little bit extra at the end. So our essential question here is, when can I use a difference of squares factoring technique? Okay, so before we begin this, we're going to go ahead and review double distribution. And I know we've done this on a couple of our notes already, but it's always good practice. So first, I'm going to do x times x. That gives me x squared. X times negative 3 is negative 3x. I've distributed my x, and now I'm going to distribute the negative 3 over. And then negative 3 times negative 3 is positive 9. And then you always check, of course, for like terms, and I do have some. I have these two right here. So I have x squared minus 6x plus 9. So here I double distributed two binomials, and I got a trinomial in the end. Okay, now let's go ahead and double distribute over here. Okay, x times x is x squared. X times 3 is positive 3x. Negative 3x here, and then we have negative 3 times 3, which is negative 9. Okay, now again, always check for like terms, and I do have some. My middle terms here are different, or are able to combine. So what happens there? Positive 3x minus 3x actually gives me 0. So these cancel each other out. And I'm left with x squared minus 9. Here I only have two terms, which is a binomial. So let's look at the difference between these two. And I want you to look at the part where we started, just the two binomials. So here in the blue and here in the blue. What is the only difference that we see here? Okay, the difference that we see here is that the one on the right, okay, what's different about that one? That one has different signs, right? The first one over here on the left has the same sign. There's a negative and a negative in between. Over here, I have a negative and a positive, okay? So that was different. The one on the right has opposite signs. Okay? Now, because of that, what happened? Because I had opposite signs, when I did double distribution, my 3x and my negative 3x canceled. My middle terms canceled. So, because there's opposite signs, the middle terms cancel. And I'm left with a binomial, okay? Now, when we have something like that, it's called a difference of squares. So when we have this, we can actually use a kind of a shortcut instead of having to factor the long way. So the difference of squares pattern. In order to use the difference of squares technique, it must be a binomial, okay? It must have a minus sign in the middle, and it must be perfect squares. Okay, now let's talk about what a perfect square is. So a perfect square is a number that can be square rooted evenly. So for example, 9. 9 is a perfect square because there's a number that when you multiply it to itself, you get 9, which happens to be 3. 3 times 3 is 9. That's a perfect square. 9 is a perfect square. Now, 16 is also a perfect square because 4 times 4, right? You can multiply some number by itself to get another number. Okay, what about 64? That's 8 times 8. 25 is 5 times 5, right? So these are all examples of perfect squares. And let me ask you this. Is 1 a perfect square? Yeah, because 1 times 1. That gives me 1. So 1 is also a perfect square. So now here's a new one, x squared. Is that a perfect square? Yeah, that's a perfect square, because what can I do to get x squared? I have x times x to get x squared. What about x to the 4th? Yeah, x squared times x squared. X to the 6th would be a perfect square also, x cubed times x cubed. So those are perfect squares. And so I'm making emphasis on this because we won't be able to do this technique if we don't have perfect squares. So you do need to be able to recognize a perfect square when you have one. Okay, now we're going to go ahead and begin with number 1. So the thing that you always want to check for, okay, is, oh, whoops, actually, let me go back. Okay, so let's look at this one that we just did here. We had that one, right? So we ended up with x squared minus 9. So sorry. All right, then you're going to check, could I use this technique on this one? Let's see. Do I have a binomial? Yeah, I have two terms. Do I have a minus sign in the middle? Yes. And I also have to have perfect squares. X squared is a perfect square, and 9 is a perfect square. So I could use this technique on that previous problem. Now, let's review the standard form of a quadratic. Standard form. That's ax squared plus bx plus c, right? Okay, so I don't want you to write anything, just kind of watch, okay? So let's identify some things. Again, you don't have to be writing. I'll let you know when you can start writing. So A equals, what does A equal in this problem? So number one, I only have two terms, but what is my A value? It's the thing attached to the x squared, right? That's our 4. What's my C value? That's the thing by itself with no x, so that's going to be negative 25. Now here, obviously, I only have two terms, so I'm missing one. I'm missing my B. I don't have a x term in the middle. So if there's nothing there, if I have no B, nothing as a number is 0. So my B is 0 in this case, okay? So I could technically rewrite this and put 4x squared plus 0x minus 25. Again, you still don't need to be writing. I'm going to erase all of this in a second and show you the shortcut. I do want to show you, however, how it's equivalent. So again, this and this are the same thing. I'm just writing it out and expanding it. Now, if I wanted to factor like normal, okay, always check for a GCF first, and I don't have one in this case, so I can draw my x. Now, how do I get that term up? How do I get this number up here? Remember, this is the AC method. You must multiply A and C together. A is 4, C is negative 25. So that's going to be negative 100, okay? And then your middle term goes in the bottom, which is 0. Now I need a number that multiplies to negative 100, but adds to 0. Well, the only time that you can get a 0 when something adds together is if those two numbers are the exact same but opposite. So in this case, that would be negative 10 and positive 10. Negative 10 times 10 is negative 100. Negative 10 plus 10 is 0. All right, so all I'm doing is splitting up that, so I have negative 10x plus 10x. Everything else stays the same, right? This should all be review, okay? So I need to factor out a GCF here. Like, again, we're doing factor by grouping, so this part is review. But still, you should not be writing because this is the long way. I'm just showing you that if you forget this technique, if you forget how to do the difference of squares technique, which I haven't showed you yet, of course, if you forget how to do what I'm teaching you in these sets of notes, you can always go back to this method here, your AC method. It will always work, okay? So I factor out 2x, and then I have 2x minus 5. GCF here is a 5, so I have plus 5 here, 2x minus 5. Parentheses match, so my first set of parentheses are 2x plus 5. My second is 2x minus 5, okay? Now, again, that's the process we're used to doing, and it will work with, of course, any type of factorable quadratic. But when I have a difference of squares, I can actually do a shortcut. So I do want you to keep in mind that answer down there, but I am going to erase it for now. So let's see if we can use a difference of squares technique with this, okay? You first check, is this a binomial, right? You always want to check those three things. Is this a binomial? Yes, two terms. Is there a minus sign in the middle? Yes. Is everything a perfect square? 4 is a perfect square, x squared is a perfect square, and 25 is a perfect square. So we're good, and we can use a difference of squares technique. Okay. When you factor something, how many sets of parentheses do you usually have in the end? Normally 2, right? So go ahead and draw 2 sets of parentheses, like you normally would at the very end of a problem, or at the very end of a factoring problem. And the reason why we need perfect squares is because we need to be able to square root it. So we're going to square root the 4x squared first. What's the square root of 4? 2. And the square root of x squared is x. So that means the square root of 4x squared is 2x. Okay? Square root of 4 is 2. Square root of x squared is x. So square root of 4x squared is 2x. Now, do you see how 4x squared is your first term in this binomial? It's going to be the first term in your parentheses. So you're going to have 2x and 2x here. Okay? Now your second term is a positive 25. Again, that minus sign doesn't really affect anything I'm doing here. I just need it in there to make sure that I can do difference of squares. Square root of 25 is 5. that 5 is going to go in the back half of your parentheses because it's the second term. Now, for difference of squares, let's look. In this first problem, how did I get my middle terms to cancel? Because right, here, I don't have a middle term. So how did these middle terms cancel? What did my signs have to be in the beginning? Opposite, okay? So, in order for this to be a difference of squares factors, or difference of square factors, I need a positive and a negative sign. If you want to write 2x minus 5 and 2x plus 5, that is also okay. You'll end up getting the same thing. But really, that's the shortcut. That's all you have to do. So, let's check this. We have 2x plus 5, 2x minus 5. So I have 4x squared minus 10x plus 10x minus 25. Okay. I have like terms here. They end up canceling each other out. So I have 4x squared minus 25. Is that what I started with? Yes. So again, you are always able to check. There's never a time where you're unable to check your own work here. Okay? Let's do number 2. You want to check for a difference of squares. Can you do it? Binomial? Yep. Minus sign in the middle? Yep. Everything's a perfect square? Yes. So you can go ahead and start 2 sets of parentheses. You're going to square root the first term, which is x squared. That gives me x in the front. Okay, the second term is a 36. Square root of that is 6. And again, if I want my middle term to cancel, my signs must be opposite, so I have a plus and a minus. Also, if you want to put the minus sign first, I don't care. I just like to put the plus sign first. That's just me. Moving on to number 3. Check for difference of squares. You always want to check. If you have 2 terms, might as well check, right? It's not going to hurt you. Forgot to mention, by the way, that you should always check for a GCF. So in the first 2 problems, I didn't have a GCF, and I forgot to tell you to check, so that's my bad. The good news is that we didn't have a GCF in those. Number 3, check for a GCF. Do I have one? I don't, so I can go ahead and move on and check to see if I can do difference of squares. First thing, do I have a binomial? Yeah. Do I have a minus sign in the middle? Yes. Do I have all perfect squares? 9 is a perfect square, x squared is a perfect square, 16 is a perfect square, and y squared is a perfect square. So I can move on, draw my 2 sets of parentheses. Okay. Square root of this one, so square root of 9 is 3. Square root of x squared is x. So I'm going to put a 3x in that one, right? 9x squared. This part is just the long part of that. So I'm doing it each part separately in case that confuses you. So 3x goes in the front. In the back, I'm going to do square root of 16y squared. Square root of 16 is 4. Square root of y squared is y. So square root of 16y squared is 4y. Okay. And again, I need opposite signs, so plus and minus. Again, if you don't believe me, you can always double distribute and check your answer. Okay. Number 4. Again, you always check for a GCF first, and I do have one. In this case, it is 2. Okay, so you would factor that out. What do you have left? 16 minus x squared. Oh, I have a binomial in the inside, so let's see if I can factor that. I have a binomial, I have a minus in the middle, and I have all perfect squares, so I can go ahead and do difference of squares. So I have 2 on the outside still, and then I have my 2 parentheses. I'm going to square root that first term first. So square root of 16 is 4. And now 16 is in the front, right? So 4 should go in the front. And then my second term is x squared. So square root of x squared is x. And for this to be difference of squares, I need a plus and a minus sign. Okay. Now, you might have been wondering at this point, what happens if I don't have a minus sign? So let's say I have x squared plus 25. Okay, I have a binomial, I have perfect squares, but I don't have a minus sign in the middle. Then that means that at this point I can no longer factor it any further. So then you would just say, I can't factor this anymore, or you can say unfactorable if you'd like. Technically, you could technically factor it, but you don't know how to factor that yet. You'll know that in Algebra 2. But at that point, you would just be like not factorable, or this is the final factored form. I can't go any further. or if you have, let's say, 3x squared plus, let's say plus 12, okay? Now you're like, okay, check for GCF. So I have my GCF, it's 3. Okay, so I take a 3 out, and I have x squared plus 4. Now on the inside, I have x squared plus 4. I have a binomial, perfect squares, but no minus sign in the middle. So this one technically isn't not factorable because you did factor it 3, but this would be your final answer because you can no longer factor it. You basically factor till you can't factor anymore. Make sure you're sticking till the end of the video because there are some problems at the end. These notes are for special cases, and right now we've only done difference of squares. Later on we'll get to something a little bit extra, which is different, and we haven't learned how to do it yet. But it's only one extra step. You know how to do everything else. Okay, number 5, check for GCF. I have one, and it is 3x. So I have 3x, and on the inside I have 4x squared minus, now 3x divided by 3x, is that 0? No. 3 divided by 3 is 1. X divided by x is 1, so I have a 1 left over. Check to see if you can do difference of squares. 4x squared is a perfect square. 1 is a perfect square. So I can go ahead and draw 2 sets of parentheses here. I'm going to square root that first term. Square root of 4x squared would give me 2x. So 2x goes in the front. Square root of 1 would just be 1. So 1 goes in the back. And then you have opposite signs. See? Again, if you forget how to do this on a test or a quiz or maybe the STAR test, you can always revert back to the old method. It will work for this, I promise. Number 6, always check for a GCF first. In this case, it is 4x. So I have x minus 3 left over. Okay, now in the middle, in my parentheses, I have a binomial. I have a minus sign, but do I have perfect squares? I don't. So that means I can't factor any further, so that would be my final answer. Again, you factor till you can't factor anymore. 3 left. Number 7, I have 5x cubed plus 40x squared plus 80x. Again, you always check for a GCF first. In this case, my GCF would be 5x. Okay, so I have 5x on the outside, and what I have left over is x squared plus 8x plus 16. Okay. Now here, after I take out that GCF, inside my parentheses I have a trinomial. So could I use difference of squares with this? No. It is 3 terms, so you cannot. So you will go back to the old AC method. Okay. So remember A times C here, so 1 times 16, that goes in the top. And in the bottom is my middle term, which is 8. Okay? Now remember, that 5x is going to stay out there the whole time because I factored it out at the beginning, so just don't worry about it for now. Okay. And then, what 2 numbers multiply to make 16 but add to 8? Well, I know that 4 times 4, positive 4 times 4 gives me 16, and those add to 8. So I will use that to split up my 8x here. So 4x plus 4x there. And then I have x squared plus 16. Now after I get to this part, I go ahead and do my GCF, right, factor by grouping. That's going to be x. You can divide out an x from both of those, so that's x. And then you have x plus 4 left over. And then over here, you can take out a 4, positive 4, and you have x plus 4 left over. And again, on the very, very outside, I have a 5x left over, and that just kind of stays out there. Remember, if you have a GCF, we want to keep it tagging along. We don't want to forget about it in the end. So my first set of parentheses are going to come from these 2 guys, the combination of these 2 guys. That's going to be x plus 4. And then the other parentheses is what I have that's matching, right? So it's also x plus 4. And then don't forget about the 5x you have on the outside. Okay, now what do you notice about what's in your parentheses? They're exactly the same. So if I had 5x times x, how could you simplify this? 5x squared. So, since I have 2 things that are exactly the same, I have 5x, which is going to stay out there because that's just tagging along, and then I have x plus 4 twice, so I have x plus 4 squared, okay? That's the only thing that you do different, is that you do everything exactly the same. You do not go any different from anything that we have learned. The only extra step at the very end you have to ask yourself is, do my parentheses match at the very end? And if they do, then you square them. Now, for example, if I have, let's say I had x, 3x, x plus 7 plus 8x plus 7, right? If I had these sets of parentheses, then I would put 3x and 8 in a parentheses, and then I would put x plus 7 in a parentheses, right? These guys are from that blue part. Can I combine those? No, then I stop, okay? You stop once you get there. If you have x plus 7, or x in there, and then you have a 7 here, your first parentheses would be these two guys, which is x plus 7, and then whatever you have that's matching is going to go in the other one, right? And if those end up matching in the end, then you might write them as one set, and you square them, okay? Again, don't do anything differently that you have been doing this whole time. The only reason why we have that 5x out there is because that was our GCF at the very beginning. That's the only reason it was there. If we didn't have a GCF, then all we would have is x plus 4 squared, okay? Number 8, again, check for GCF first. It is 2y. So you have x squared plus 2, oh not plus actually, minus 2x plus 1, okay? 2y divided by 2y is not 0, it is 1. I almost said the wrong thing, okay. Okay, 1 times 1 is 1, that goes up top, and then I have negative 2 down there because I wanted to add to negative 2. Two numbers that multiply to make positive 1 and add to make negative 2 is negative 1 and negative 1, okay? So I have 2y just sticking on the outside there, and then I have x squared minus 1x minus 1x plus 1, okay? Again, I'm just splitting this guy up. And then I have 2y still out there, factored by grouping here. So I take out a x from both of these, and I can take out a negative 1 from both of those. Remember, take out a negative because that first term is negative. So you have x, and then x minus 1, minus 1, x minus 1. Okay. So, again, what I have on the outside of my parentheses here is going to go into its own parentheses. And then I have two things that are matching. So those go into its own set of parentheses. And then that 2x is just going to stay out, or that 2y is going to stay out there. Now you also want to check, do my parentheses match? And they do, they're exactly the same, so I can rewrite that and put x minus 1 squared. You're like, do I have to? Yeah, you do have to, because it's not going to be in completely simplified factored form. Last one, okay. Now this one's a little bit different because we have two letters in here, two variables, x and y, and they're attached to every single variable. As always, you want to check for a GCF, and do you have one? No. Now, I know it looks a little scary because of the y squared and the xy in the middle, but you treat it just like normal, okay? To get the number at the top, you multiply your a and c. 9 times 16 is 144, okay? And then negative 24 goes in the bottom. Two numbers that add to make negative 24 but multiply to make 144 is negative 12 and negative 12. Negative times a negative is a positive. Negative 12 plus negative 12 is negative 24. Again, as we factor, or as we do this, remember that first term stays the same, and that last term stays the same. The only thing you're doing different, you're splitting this guy up. So that's going to be negative 12xy and negative 12xy, right? We got that from over here, our negative 12s. Okay? Again, your letters, variables, everything stays the same. The only thing you're changing is the numbers, and that's just the middle term number. I'm going to factor out a GCF here by grouping. Now, at the beginning, I didn't have a GCF, right? So for this one, I had 2y. For this one, I had 5x. So that had to stay along with me the entire time. But I don't have one here, which is nice, so you don't need to worry about that. GCF here is 3x. So I have 3x, and then I have 3x minus 4y. Okay, that's what I have left over. Over here, I have negative 4y that I can take out of both. And what I have left is positive 3x minus 4y. Now, you always want to check to make sure your inside parentheses match, and they do. So that's a good sign we did this correctly. And then you have 3x minus 4y for your first set of parentheses. Okay? And then you always write your matching parentheses down as well. Okay? Matching ones here, matching one here, goes down here. Okay? And since those are exactly the same, then I can write it as 3x minus 4y squared. And I don't have a number attached to the outside of this one because I didn't have to factor a GCF at the very beginning. All right, so those are our special cases here. We have a difference of squares cases where we can do that neat square root trick and then just do the plus and minus sign. And then you have the where you have the duplicate factors, where you have x plus 4, x plus 4, or x minus 1, and x minus 1, and then you write them twice. Or you don't write them twice, but you condense it and put a square on top. But that is pretty much it. Again, if you have any questions on